Hey Math Wonders, in this lesson you will learn how to identify functions and to find the domain and range of functions and relations. This will be page 3 in your table of contents entitled Relations and Functions. So your vital vocabulary for this lesson is relation, domain, range, and function. What are those? So relation, in the previous lesson we saw that relationships can be represented by graphs, and relationships can also be represented by a set of ordered pairs called a relation. So a relation is simply the collection of all of one variable with another variable. So for instance, in the scoring system of some track meets, first place you get 5 points, second place you get 3 points, and third place you get 2 points, and fourth place you get 1 point. This scoring system is a relation, so it can be shown by ordered pairs. For instance, 1 and 5, 2 and 3, 3 and 2, and 4 and 1. You can also show relations in other ways, such as tables, graphs, or mapping diagrams. So we're going to express the relation given as a table, a graph, and a mapping diagram. So in a table form, we're simply going to collect all the x values under the x and all the y values under the y, like this. On a graph, we can simply graph these points using x and y values to plot the ordered pairs. And a mapping diagram looks something like this. We're going to write all the x values under x and all the y's under y's, and we're simply going to draw arrows from each x value to its corresponding y value. Okay, now you guys give it a try. You're going to express the relation given as a table, a graph, and a mapping diagram. This is your guided practice, so you'll pause the video now. Okay, welcome back. First, in the table form, we're simply going to put all the x values under x and y values under y. So there's this relation in a table. On a graph, we're going to plot the ordered pairs, the x and y values as ordered pairs. This happens to look like it's linear, which means it's making a line. And as a mapping diagram, it's going to look something like this. For every x value, we're going to use arrows to point to their y values. Okay, how'd you do? So in addition to identifying relations, we need to be able to identify the domains and ranges. So the domain of a relation is the set of first coordinates. In other words, it's all the x values of the ordered pairs. In addition, the range of a relation is the set of second coordinates, or the y values of the ordered pair. So the domain of the track meet scoring system is 1, 2, 3, and 4, all the x values, and the range is 5, 3, 2, 1, all the y values. So we're going to give the domain and range of this relation. I want to identify all the x values. That's going to be my domain. So it looks like it starts at 1, and then all the numbers past 2, 3, 4, all the way up to 5. Now, in this case, being that it's a line, it's a continuous graph, as we learned last lesson, it contains all those fractions and decimals in between the numbers 1 and 4. So we actually have to use a special inequality, a compound inequality rather, to identify all the values. Likewise, my y values, it looks like it stretches from 3 to 4, or rather from 4 to 3, and all those fractions and decimals in between 4 and 3. So we have to express that as a compound inequality. So the domain value is all x values from 1 to 5. The range is 3 to 4. So the domain would be x is greater than or equal to 1, because 1 is a data point on this graph, and less than or equal to 5. So notice this is essentially two inequalities in one statement, thus making it a compound inequality. The range would be y is all numbers greater than or equal to 3 and less than or equal to 4. Notice these numbers have to meet both these criteria, both greater than 3, greater than or equal to 3, and less than or equal to 3. All right, so just be mindful of when you need to use these kind of compound inequalities. The domain and range of this relation, well, the domain is simply going to be all the x values, 1, 2, 5, and 6, and the range is going to be all the y values, 0, negative 1, and negative 4. This time, this is a discrete set of numbers, so I can just list the numbers themselves. It's not continuous like the previous. And lastly, looking at a table, once again, we've got distinct numbers, so I can list the numbers in a set. 1, 4, and 8 for the domain, and 1 and 4 for the range. Those are my dogs. Alright, so a function is a special type of relation that pairs each domain value with exactly one range value. And that's a very important distinction here. Each domain value with exactly one range value. So that means you can't have a domain value that's been given two different range values. For example, in this set of numbers, we're going to tell whether the relation is a function. So I'm looking at the x values. 3 is assigned to negative 2, 5 is assigned to negative 1, 4 is assigned to 0, and 3 is assigned to 1 here. Well, if the criteria is that every domain value has exactly one range value, then that's not the case here, because these domain values have two different range values. So this would not be a function. Each domain value does not have exactly one range value, so the domain value 3 is paired with the range values of negative 2 and positive 1. Not a function. By contrast, using this mapping diagram, we see that though we have arrows pointing to the same y value, does each x value have a distinct y value? Negative 4 is assigned to 2, negative 8 is assigned to 2, 4 is assigned to 1, and 5 is assigned to 1. So this is okay. The relation is a function. Each domain value is paired with exactly one range value. It's a problem if 5 were assigned to 1 and 5 were assigned to 2. That would not be a function. Looking on the graph, the domain and range of the relation, and tell whether the relation is a function. Now on a graph, again, we're looking at the x values. So this stretches all the way from negative 5 to positive 3 for your domain values. And our x values range from 1 to negative 2. There's our x values, our domain. Here's our y values. So the x values are greater than or equal to negative 5 and less than or equal to 3. Y values are greater than or equal to negative 2 but less than or equal to positive 1. Is it a function? Well, ask yourself, is each x value assigned exactly one y value? So if I'm looking here, let's say at negative 2. Negative 2 has a value of positive 1. It's also assigned a range value of negative 2. So by that criteria, this would not be a function, guys. Nearly all domain values have more than one range values. That's true, nearly all of them. This domain value doesn't have one, nor does this one, but nearly every other one has another range value. Not a function. Okay, you guys give it a try. You're going to give the domain and range of the relation and tell whether the relation is a function and explain. Pause your video now. Okay, welcome back. Let's see, let's take a look at those ordered pairs. Ideally, you identify the domain, all the x values, and you identified all the y values in the range, and you identified that this was a function because each x value is assigned exactly one y value. In letter B, your domain is given as 2, 3, and 4, and your range is -5, -4, -3. Now, the trouble with this one is, of course, that 2 appears to be assigned a range value of -5 and a range value of -4, and that's not going to work. That's not a function. The domain value 2 is paired with both -5 and -4. Not a function. So in this lesson, you learn how to identify functions and how to find the domain and range of functions and relations.